can maybe introduce yourself, introduce the company, and just explain a little bit about where you operate, what products, what services you provide.
Yes. Okay. So my name is Klaus Buchheim, business development here for Klepsydra. I have a background as an electrical engineer, spent now more than 18 years in the European space industry, mainly on the hardware side, and now with Klepsydra more on the software part of the whole development. Klepsydra itself is a Swiss SME, so we're located in Switzerland. We are now about 6.5 years old, and our focus is actually on onboard data processing, onboard AI for satellite space systems, and make this as fast and as efficient as possible.
Great. Okay. So 6.5 years old. That's not veteran, but it's actually a little bit older than some companies in this space. So was the company created for a particular project or mission? How did it emerge? What were the problems that you saw needed solving?
It's actually quite an interesting story. So our founder has a background in the Swiss banking industry, actually high-speed financial trading, where speed and milliseconds indeed mean a lot of money. And in parallel, he was doing his PhD in aerospace. And in his tenure as a software developer for Swiss banking, he learned a certain specific way of programming, which is called lock-free programming, which is used exactly for extreme low latency type of products. And when he saw what he learned in doing his PhD, he thought, hey, I know something that the space industry could use, because they operate on very resource-constrained system, but need to process a lot of data. And that was the trigger point on funding the company and building the product that today we have.
Okay, so maybe tell us then a little bit about what are the kind of applications that would need AI inferencing, would need this low latency kind of software that you create.
Yeah. So it's basically a lot of applications, right, that are looking at increased autonomy for satellites. And as we are making a layer to accelerate these applications, we're quite application agnostic. So what we have seen, I would say the classical example is an Earth observation satellite or remote sensing satellite, right, that instead of sending down just pictures or the data, would already extract data on board, either for early alert, right? So my example is always, right, ship here, take a look, right? And then you just send that information instead of all the images with vast empty ocean. The other aspect, which is already, I think, quite used often, is data reduction, right? So again, if you have remote sensing in the visual spectrum, clouds are less interesting. So you can use AI-based processing to throw away all the images that have too many clouds on it, and thus reduce your downlink volume, just save money and time processing on the ground. But we have seen now this being extended to other sensors, right? Not just imaging. You can very imagine this on the SAR side, again, retrieving data. We see applications in the telecom field, where maybe it's less processing data, but it's, for example, rapid anti-jamming. So an AI on board can detect jamming attempts, enables frequency hopping, autonomous docking, rendezvous maneuver, right, up to re-entry vehicles, on launcher sites. So I don't know what SpaceX is doing, but in principle, right, you have a type of, so it's up to predictive maintenance on systems that the satellite is actually alerting before something happens on the ground, and you don't have people on the ground having to sift all the telemetry data. The satellite does it by himself, up to the autonomous operations in large constellations where you have in part AI on board of the satellite and part AI on ground. So it's an extremely broad field, and I think every day people invent something new.
Right. No, exactly. And I was going to say, obviously, I think AI has been in the public consciousness for 3 or 4 years since ChatGPT burst onto the scene. Obviously, it's a lot older than that.
Yes.
But how have your services, how have things innovated yourselves in the last few years compared to 6.5 years ago when you first started?
So what we see, right, I would say 6.5 years ago, I use this analogy, right? It was a topic that the intern did in the corner of the lab, right? And he put some, not that the intern is a bad engineer, but right, he glued something together, quick and dirty, proof of concept, right? Oh, great. Hey, actually AI has some use for, for example, onboard satellite system. And now when you want to look into a larger deployment, larger fleet, you need to think differently of the problem, right? So again, performance, right? Okay, this was a simple AI. What can I do something, more complex? Can I actually not run this maybe on the cost processor that I run on the IOD? I didn't care it break down in 6 weeks. How can I run it on a processor that lasts 7 years, right? So red hot processors with all its limitations. Do I need certified software, right? Or can I still use an open source, right, stack from that I grabbed from the internet just to put a demo together? And it's all these changes that we see, which I think is the majority of the solution, right? We have done the proof of concept, we see the benefit, and now it's like, okay, what do I need to do? What do I need to change to make it a larger deployment so that I don't rebuild my AI application every time I want to change something, that every time I need, again, 5 years development time, right, for a new mission, things like that. And that's what we have seen in the discussions and where our solution contributes to.
Right. Okay. And is it just like you did? I think what I've seen is you describe yourselves as software,
Yeah.
but does it come with hardware? Like what is if a client comes to you, if a customer comes to you, what do they get? What do they need to know? What information do they need to provide to you so you can build them something?
So actually, we only provide software, right?
Okay.
So in the end, they get a piece of software library that they can integrate into their overall software stack. Our software in general runs on a whole variety of different hardware. And either the customer gets, if you want the full scope, he has different hardwares, he gets many different versions of the same software, or he tells us, hey, I need your inference framework for, this ARM core, and then he gets a dedicated build from us. That's the thing. But we provide software only.
Okay. And so does that make it, I mean, presumably there are still differences in providing software in space compared to on Earth. So what are those differences that your software needs to be, that how it would differ to an application software piece on Earth, for example?
So for space, what we do is, right, we're currently undergoing a certification from ESA according to their software standards. And what that then, when you have achieved that, entitles you a little more rigid, right, in terms of update. Because if we would implement changes in a certified element of the software, right, we would have to do recertification, things like that. So on the ground, you basically could go a bit quicker, right, in terms of updates. So on the space, you maybe think a bit more. But to be honest, that's it. That's the difference. So if someone in the end says, I don't care, right, he can use, in brackets, the ground version, which maybe doesn't have an official stamp, but could be certified. And we're actually doing more the reverse, right? We're using the space certification and it's, the security reliability that comes with it, actually in non-space markets, right? Where we go in and say, hey, your industrial automation thing maybe should also need a reliable AI inference engine for not losing control, right? And hey, we are certified according to space standards.
Okay, got it. And how much like AI knowledge or expertise would a customer need to have before they come to you? Or can you provide almost like an end-to-end AI software solution?
No, so he needs to have AI knowledge, right? We don't provide the models,
Right.
Nothing in that. We provide the engine that runs the model fast on the space processor. But maybe he also just needs the AI knowledge, right? Because he doesn't need to worry about high performance inference because that's what our framework provides. And we see also in the, I would say it's a slightly different capability, right? Training an AI properly is a different discipline than writing efficient software code, right? So I think that we're supporting this, that in brackets, the AI engineer then can really focusing on building a proper AI model, right? And the proper training, and hasn't to worry about later about the performance on the deployed device.
Okay, got it. Could you walk me through an example of one of your software deployments into space? You don't have to name names of the client, obviously, but maybe just describe how your software helped them achieve something that alternatively they wouldn't have been able to achieve.
Yes, sure. So we had a case where the customer was looking to build, let's say he needed increased processing capabilities to detect very low weak signals, right? So it was improving the signal to noise ratio using an AI algorithm. That was his main task. I think the application background linked to that was, for these AIS systems. And he had trouble running that. It was an older NVIDIA GPU, and they had trouble running it. So basically, the computer was running on the max in achieving what they want, and they wanted to get a bit more performance out of it. So for us, it was interesting. Our GPU version was not 100% ready. So, right, we basically took our framework, said, okay, we adapted to this particular GPU. And then we took his model. We didn't change anything, right? We implemented on the ground, tested on the ground. And then the complete software stack was uploaded to his satellite onboard computer and executed there. And then, right, he could get the better signal improvement, which, what I understand, right, allowed them then to better detect, faster, more securely these ships. That's what I understood.
Okay.
But a lot of times, to be honest, we hardly know the full application.
Sure. And so, I mean, that sounds like it can be quite a speedy process then. What's the general kind of timeline for people coming to you and getting this kind of launched?
So I can give you a non-space example that just 2 weeks old. So we had another partner that was building, they had a running algorithm for, I think in this case, it was a self-driving car. And we want to do a joint demo, and he wanted to demonstrate this to the customer. He started on Monday morning, Friday evening, everything was running, and he had the 20% improvement. So, running on his system and everything. And space in principle could be very similar. I think there in the end, it's then the uplink that maybe is the
right
the part.
Sure. Okay, interesting. That is significant. So you mentioned a little earlier about some of the things that are emerging that you've seen change from 6.5 years ago. What are you working towards in the future? Maybe forecast 2, 3, 4, 5 years. What kind of developments do you need to future-proof now inside your own products?
So I would say the two main keywords beside, I would say, general housekeeping. So one is definitely the emergence of neuromorphic processors, right? So BrainChip is, for example, a popular name, especially in the space industry, and they getting interest because they offer for some task, a very low power capability. So for us, implementing support for these type of accelerators is a key next step that we're actively working on. And the other part is, of course, the emergence of LLMs, not only right in the type of ChatGPT, but also potentially, well, LLMs is the wrong term, right? Transformer-based AI models, also for the type of edge AI. And today we don't support the transformer layers yet, and that is the other thing that we're working on this year to build the support and provide the same acceleration to these transformer layers in models.
Okay, wow, that sounds interesting. How long is that going to be away, do you think?
We hope to have a type of an alpha by the end of this year, but I want to be quite open. Things sometimes, right? We have some ESA project and things, and sometimes project work takes a bit priority over product development. But that is what we have on the roadmap, and we think on the neuromorphics, it's about Q1 27 where we are. We have announced a partnership with BrainChip on that exactly to accelerate that work. So this is something we're starting actively to work in to look how to implement that. What are good targets to showcase that capability?
Sure. Great. Klaus, thank you so much.